we normally use what is called the SI units in physics. Now, the SI units makes use of a number of what is called the base units. So these are units from which other units can be built up. Now, these base units are as follows: kilogram, second, meters, Kelvin, mole, and ampere. Now, these units are units for 6 different physical quantities. Kilogram is for mass of a substance, of an object, whatever. Seconds is for time. Meter is for distance, for length. Alright. Kelvin is for temperature. And mole is for the number of particles. And ampere here is for current. Now, not water current or any other kinds of current, but specifically electrical currents. Now, from these units, all other units in physics can be built up. Now, there is actually one more that I've not mentioned yet. It's called the Candela. That's about the strength of light. So I shall not talk about that for now. I shall mainly focus on these 6 units. Right. Now, let me say a little bit about how we can use these to build up other units. So let me look at some examples. Right. Clear those. I'm just going to make the brush size a little bit smaller. Okay. Right. Let's quickly write down what we have so far. So we have kilograms for mass, we have meters, we have seconds, we have Kelvin for temperature, we have, let's see, what do we have? Ampere for current, and mole for amount of substance. Now, kilogram and meter. Let's think of something. Right. What is easiest? Let's say speed. Right, speed. Now, speed, the unit of speed is none of the above, but it can be related to those. Right, because we know that speed is actually distance divided by time. Okay, so the units would therefore be the units of distance divided by the units of time, and in this case it would be meters over second. And so we can write that out, meters over second, and we would normally write this in this way. The having meter over second might be a bit cumbersome. It looks like a fraction, so we might either write meter stroke second, or we might write meter second to the power of -1. Now we do this in physics quite a bit, but in everyday life we often use the stroke. So we've seen an example of combining meters and seconds to give speed. Now let's look at something else. Let's look at volume. Okay, volume. Now volume is again none of this, but we know that volume is, if you have the volume of say a cube, you take the side, each of the three sides, and multiply them together. So it is actually a distance. Right, let me write it this way. So volume, right, if let's say I have a cube like this, I would have a base. The base would have a length, a breadth, and the cube itself would have height. So it will be length times base times height. That would be the volume. Now, but each of these has the same units of meters. So I can do meters times meters times meters for the units, and then we can just simplify it and call it meter cubed. So that's the unit for volume, for example. So that uses the length. Now let's think of something else we can use. Say kilogram, right? Say the mass of this is let's say m, and we are interested in the density. Now density is the amount of mass for a unit volume. So if you think of density, let's see. Let me choose a different color. Right? Density is actually volume divided by, not quite volume, is mass divided by volume. That's density. Now we can think about, we know that mass is in kilograms, so that's the unit for mass, and volume we already know is meter cubed. So there we have density. The units of density would be these two units combined, kilogram and meter cubed. And we would often write this as either kilogram stroke meter cubed, or say kilogram and then meter to the power of -3. So that's that. Let's now, so we have done kilogram, meters, seconds. Now let's do one or two more examples. Let's say Kelvin, right? Kelvin, that would be temperature. So I want to think of an example that involves temperature and also ampere and maybe mole. All right. Now Kelvin. Let's see what we can think. Right. So let's say we think of we have a, let's say we have a little piece of object. Okay. Now let's say I put a fire. No, fire is red color. So let me make a little fire below here. Now there's this fire here. Okay. And it heats up the piece of metal. Okay. So this temperature will go up. Now the fire will give heat to the object. Now let's see. Now, but then I would need an energy, a unit for the heat, which I don't have yet. So let me first talk about the energy, the units for energy. Now the units for energy, let's see. Energy is it comes from the work that we do. Okay, so we know that work. Okay, I need to digress a bit. Let's say if I have energy, right? Energy comes from the work done on something, so that's work. And work in turn comes from if you push an object for some distance, it will be the force times the distance. Okay, and that would be let's see, now we need the units for the force as well. So let me build this up. And now the units for force. Force is mass times acceleration. So that's m times a times the distance. Okay. Now acceleration is the change in velocity. So this is mass times velocity over time times the distance. Now that's a lot of units. So if I can put all these together, I will get kilogram times velocity is meters per second over time is second times d is meter. Okay, so now I have energy in terms of these units. So if I come back to this heat, let's say I'm interested in how much energy I need to put into this substance per second. Now that is called a heat capacity, right? Heat capacity. So heat capacity is the amount of heat that I need to put in. Okay, for each Kelvin that I want to go up in. So that's over the temperature. The temperature change. Okay, so it would be this units divided by Kelvin. So let me choose another color. So it would be this unit, which is the unit for energy. It will be kg. Then you see there's a meter squared, and over second squared divided by temperature is in Kelvin. So there. Okay. Now later on in the in later videos, I'm going to talk about how we can make more units from A for ampere and the mole that we have here.